Uh, Hello, dear students and academic staff. Welcome to this webinar. Today, we organized a online webinar for dear Professor Vandhana Devi. She is our guest lecturer for today to present a lecture about water treatment technologies for rural community option and opportunity. At the first of the webinar, I would like to ask Mr. Shwana, who is the Civil Engineering Department at the University of Raparin, to give his speech about the importance of this academic relationship, international relationship, and also we have another question: why you choose this topic? Please, Mr. Shwana, explain it for us.
Yeah. Shall I start, Mr. Aras?
Yes.
Yeah.
Think so.
Good morning, everybody. On behalf of our department, I warmly welcome the chief guest, Dr. Vandhana, who is she's from Civil Engineering Department at the KCG College of Technology, and she is head of department. Now she's with us to present a lecture entitled Water Treatment Technologies for Rural Communities, Options and Opportunities. Why we choose this topic? We choose the water treatment technology since drinking water has an international impact. Also in Iraq, drinking water is one of the most crucial issues because all water sources comes from the countryside. Therefore, water management and treatment process is our government needs. And I want warmly welcome you again. We're so honored for having you this morning as a guest lecturer. And I want to say the guest lecture are highly useful medium to provide technical knowledge to students. And it's also extra variety to the classroom routine and universities. This chance provide the students with lectures, presentation, opinions, personal experience, can reinforce the teachers and students. I am asking our guest lecturer, dear Dr. Vandhana, to start with her expert talks. Thank you very much.
Okay, thank you very much, dear Mr. Shwana, for your remarkable speech regarding to this webinar. And I would like to give a brief biography about Dr. Vandhana Devi. She is head and associated professor of Department of Civil Engineering at KCG College of Technology, Chennai. And she completed her Bachelor's of Civil Engineering from Crescent Engineering College, University of Madras in 2001. Subsequently went to finish her master's degree in environmental management and PhD in civil engineering from Anna University in Chennai. Her area of interest includes environmental engineering, pollution prevention, construction materials, and advanced wastewater treatment. Her primary research goals are directed toward environmental prevention and protection. She has conducted various webinars among students. Excuse me, there is a noise. Could you mute your mic, please? I don't know, this noise is my computer or Mr. Chomani. At the hall, there's any noise or not? It's good.
It is muted.
The sound is good.
Yeah, it sounds good.
Okay, thank you very much. Well, we said that her primary research goals are directed toward environmental prevention and protection. She has conducted various webinars among students to cultivate the habitat of preventing our motherland. Within a span of 18 years, she has published in more than 45 international and national conferences. She has authored a book titled Air Pollution and Control Engineering in 2019. in Magnus publication. She has reviewed many international papers for publication, and she was reviewer of many international journals like Ecological Engineering, Economic of Disaster and Climate Change, Institute of Exploring Advance in Engineering, international journals. Also, Dr. Vandhana conducted various technical programs for AICTE and ISTE sponsored events at various colleges. To mention a few, she conducted 1 week online FDP of curriculum for sustainability phases organized by Velimal Engineering College. She has received a grant, also 75,000 rupiah from SERB in New Delhi for organizing 3-day seminar on artificial intelligence in construction, and also received a grant of 1 lakh of rupiah from Department of Science and Technology in New Delhi again for organizing 3 days international conference on innovative technology for sustainable built environment. And she received a grant of 30,000 from Indian National Science Academy for organizing 3 days international conference on innovative technology for sustainable built environment, and also received 1 lakh grant from Department of Science and Technology from New Delhi for organizing 1 week workshop on urban disaster, natural failure of human negligence. And she received a grant 50,000 rupiah from Department of Science and Technology for organizing another day national conference, sustainable and emerging technology in civil engineering, and also received 25,000 rupiah from Council of Science and Industrial Research for organizing our 1-day workshop on protective plan and design of structure. She has contributed toward professional bodies in civil engineering domain by involving herself as a resource person, and also she is a life member of ISTE, IES, IEAE, and INCS institutes. Under her leadership, the department got national award winner in IICTE Best Industry Link Technology Institute in 2020 as Best Emerging Department for 2020, and she received Young Achiever Award by Institute of Exploring Advance in Engineering. And also she is currently focusing on developing new lab experiment as a part of IIT Pulse virtual lab research program, and she also leads the team as nodal coordinator of virtual labs. That's the short bio regarding our guest lecture. And also we hope we have a cooperation for the next and win some grants for our university. Actually, because we are a new university, we need more help from international experts like you. Now it's time to you. Please start your presentation, and again, welcome to our university.
Thank you. Good morning. Am I audible?
Yes, it's good.
Yeah. Good morning, dear students and faculty of Civil Engineering Department, University of Raparin, Kurdistan region of Iraq. And thank you so much, Mr. Aras Ahmed Hamza, for introducing me to the audience. And I would like to thank Shwana Brahim Hassan also for initiating the collaboration between KCG College of Technology and between the University of Raparin. Okay, so very good morning. Hope I am audible loud and clear to all of you.
Yes. Yes.
Yes. And yeah, thank you. I would like to thank the management of KCG College of Technology principal and also the head of the Department of Civil Engineering at University of Raparin for giving me this opportunity to deliver the technical talk on, let me share my screen. Yeah, hope it is visible. Yes.
Yes. Now it's visible.
Yeah, thank you so much for giving me the opportunity to deliver expert talk on water treatment technologies for rural communities, especially for regions of Iraq, parts of Kurdistan, near your university, I would say. What are the options and prevailing opportunities? So I would like to deliver this topic for the benefit of budding civil engineers. Yeah, let me proceed. So, sir has given a brief introduction about myself. I'm heading civil department at KCG College of Technology, which is located at Chennai, India. So, my presentation will be about the objectives of unit operations and process, and then I'll be elaborating on the design and functions of water treatment plant. A few operations like aerators, coagulators, what is a flocculator, and the principle behind sedimentation and clariflocculator. What are tube and plate settlers? What are pulsator clarifier? And we'll be going on to the sand filter, like rapid sand filter and slow sand filter, the types of filters we have. And then the final topic will be about the disinfection and residue management. And we'll be discussing about the opportunities and options for Kurdistan, Iraq. Yes, coming on to the water treatment operations. Before I start with the unit operations and process, I would like to emphasize on the objectives of water treatment. So I was told all of you are civil engineering students, and some of you may be thinking civil engineering is just construction. Construction of buildings, development of infrastructure, that's all, right? But we don't stop with that. I always say civil engineers are only next to God. Okay, so we are the boss. To put it in simple words, we are taking care of the supply of water. When I say water, it is pure water. Okay, purified water, treated water to the public. You can also imagine who is supplying water to the your university. Just start thinking. Yeah, who are all working behind this water treatment process? It is all environmental engineer who is a civil engineer, right? Okay, so there are a lot of methods and process in water treatment, like right from the source. For example, the source for your water supply in your university will be the nearby river. I think I must be correct, the Kosa river or the Aksu river. So from there only we are going to collect the water, take it to the water treatment plant, which is being done by your Erbil Water Directorate. So you have 3 water treatment plants in your locality. You have Soren Water Treatment Plant, Kirkuk Water Treatment Plant, and Kani Water Treatment Plant. I hope your faculty would have taken you all for an industrial visit to all these water treatment plants. If not, also we'll arrange one for you all. So these water treatment plants, they collect the water from the river, Aksu River or Kosa River, and then they are going to treat the water. So the budding civil engineers, you guys are going to learn what are the treatment options available, what's happening in the water treatment plant at Kirkuk. Why I'm pointing out this Kirkuk water treatment plant is, this is the treatment plant, very huge one. It provides potable water for over 1 million residents, okay, which is a big number, I would say. So that is why I'm pointing about this Kirkuk water treatment plant. So we, the civil engineers or the environmental engineers, are the ones who are taking care of the water supply, water treatment, water distribution to the public. Hope the point is clear. Some of you may be learning, why as a civil engineer are we learning about this water supply, wastewater treatment and all. So we are only designing the landscape of any city, and hence the water, which is an elixir of life, is being taken care by a civil engineer. Yes, so without water, we cannot imagine a day. And similarly, without food, clothing, shelter, we say, no, in that the shelter, it is also being taken care by any civil engineer. right? So the water treatment, the major objectives will be to remove the objectionable odor and color. Okay, sometimes your river, which in case of, in my place, in India, I'm saying, even in your place, it is not crystal clear like earlier days, right? So it is all polluted. Some people throw some kinds of garbage into the river, right? So what happens? All this toxicity, even industries, they are discharging their waste into the river, right? So all these unpleasant taste, odor, objectionable color, everything has to be removed from the water. So that is the major objective of water treatment, okay? And then we'll be removing the dissolved gases present in water, okay? And we also take care of the removal of suspended solids, colloidal solids, and dissolved impurities present in water. Sometimes when you look at the water, it may not be turbid also, but that will contain dissolved impurities, total suspended solids. Okay, so you are not supposed to consume the water with high TDS, total dissolved solids, right? So our objective is to remove or reduce all these contaminants present in water. Okay, and some of you would have experienced in major cities, I would say, when you use water for bathing or for washing your clothes, nowadays we don't find leather at all. What is the reason for that? Because the water is hard in nature. Okay, so only this hardness property in the water is not allowing the water to produce leather when it reacts with soap. So the content of hardness present in water can also be reduced or removed by the water treatment methods, which we are going to discuss, right? And then major problem is the disease. Suppose if we are not treating the water, what's going to happen? Emerging of diseases. Okay, there are a lot of waterborne diseases, right? That is why we say the water has to be treated, it has to be boiled before consumption, right? So the disease producing microorganisms must be removed from water. Okay, and this water, we, the civil engineers, are going to make it fit and suitable for domestic purpose, for residential purpose, as well as for industrial purposes. All your industries, textile industry, leather tanneries, you are wearing leather jackets, leather belts, okay, leather bags, everywhere. Even your paper industry, textile industry, everywhere they need water. Okay, so we are only making the water suitable for domestic and industrial purposes. Okay, yeah, and there are two more things. It is unit operation and unit process. Let me tell you the difference between both operations and process. Okay, unit operations are the treatment done by physical or mechanical methods. For example, screening. Okay, you can see, right? Screening, filtration, sedimentation. All these are the unit operations. And we have unit process, which are nothing but the treatment done by employing chemical or biological methods. I repeat, the unit process are the treatments done by employing chemical or biological methods. For example, coagulation, chlorination, and so on. So I'm not going in depth about each and every process right now. I have just discriminated the unit operations and process. Hope I'm clear with the objectives of water treatment and the unit operations and process. Okay, yeah. Now coming on to the unit operations, these are the major operations we have in a water treatment plant. The first thing, from your coastal river, when we are going to fetch water, it may even contain dead animals, right? Then branches or twigs of big trees, or some clothes, you would have thrown something. So all these are going to come to your water treatment plant. So the first operation is the screening, which is a mechanical or physical method by which all these larger objects will be removed. right? Or else what will happen? All your other unit operations in process will get clogged. So the first operation is the screening, and then comes the aeration. So that is a very important unit operation which takes care of the gas transfer. So the carbon dioxide present in the water will be removed during the aeration process and oxygen is introduced into the air. So by doing this, you are increasing the dissolved oxygen content present in water. Okay. All right. Now the next process or the operation is the sedimentation. So I'll be spending more time on elaborating the sedimentation method in my upcoming slides. Okay. And then we have filtration, and the final one is the disinfection. Disinfection, just you are going to remove the pathogenic bacteria. Clear? This is the flow chart showing the entire water treatment process happening in your water treatment plant. For example, in your Kirkuk or Kani water treatment plant, when you go to the plant, when you visit the plant, you will you can have a glance of all these treatment process. Okay, you have the influent from your source of water, Aksu River, and then screens which are placed at an angle of 30 to 45 degrees to the horizontal, and then we have a lime rapid mixer. Then comes the flocculator, sedimentation. All these tanks are meant for a simple process for settling. Okay, the heavier particles settle down. So when I say sedimentation, it is otherwise known as settling due to the gravitational force. Okay. In order to speed up the process of sedimentation, you can even add coagulants like aluminum sulfate, Al2SO4, 10H2O. You can add them so that the detention time will be reduced. For example, the plain sedimentation tank, if at all if the detention time is 6 hours, if you are adding coagulant, then it becomes 2 to 3 hours. 2.5 hours will be the detention time for a coagulant tank, right? Then what happens at the bottom? We always provide some space for accumulation of sludge. So the sludge has to be collected, and then we can reuse the sludge. Disposal of sludge is a different topic. I'm not going to touch upon that today. After sedimentation, we have filtration. So when I say filtration, the usual general process of filtering the water. So we have dirty water on the top, which has to be filtered, and below that we have sand, gravel particles, and at the bottom we will get clean water over a period of time. So when I say filtration, we have two methods, two types. One is rapid sand, quickly. It all depends on the rate of filtration. Okay, 2,500 liters per heart per meter square is the rate of filtration of a rapid sand filter. And we also have a slow sand filter. There are a lot of disadvantages of using a slow sand filter, and it is like outdated nowadays. We, all of us, being in a developed country, we have gone for usage of rapid sand filter. Okay. So the process of rapid sand filter also we'll be discussing in today's lecture. Then comes the disinfection. You are just going to add chlorine or bleaching powder so that you are removing all the pathogenic bacteria from the water. Then we have the storage reservoir, and the treated water will be stored depending on the population of the city or town, and then finally it will be distributed. You can even make use of pump. Civil engineers must be learning it in your fluid mechanics, right? Centrifugal pump, reciprocating pumps and all, right? So we'll be making use of the pump. We have a pump house where the storage water will be distributed to the nearby city. You can either send it as a gravity method, okay, or pumping method, or combination of gravity and pumping method, depending on the location of the terrain. Fine. Hope I am clear with the flow chart of water treatment process. Yes. Let me move on to the sedimentation tank. So based on the shapes, we have three types. One is rectangular, then comes circular, and then hopper bottom settling tank. Sedimentation tanks are also known as settling tanks. Yeah. This is how a rectangular settling tank looks like. Hope you guys are able to see the inlet for raw water. This is the raw water from your source. I told you this is Aksu River. From there you are having this water. And the unit operation before the sedimentation is the screening. Okay, so I can say it is coming from the screens, not from river directly. It is coming from the screens. Okay. And then we have baffle walls. The water is allowed to pass through that and circulate through the baffle walls. So this is how the settling tank works. And at the bottom, we have the outlet to flocculator. Okay. In some cases, the inlet could be on the left-hand side and outlet on the right-hand side. So that all depends on the design of the tanks. And this is how a circular settling tank looks like. Okay. So we have an overflow weir. And we also have a tapered bottom at the bottom, towards the bottom of the tank. Okay. And we need to give some space at the bottom for accumulation of sludge. Hope all of you know what is a sludge. Sludge is a semi-solid material, something like waste, which is obtained from all the water treatment process. Okay, I was telling you the heavier particles settle down, right? So these heavier particles over a period of time, say for a week or within a month, they'll form a semi-solid material. So that is known as sludge. Whereas this sludge is rich in nutrient value, and you can even use it as a fertilizer, manure for your trees, gardens and all. Okay. In fact, in Chennai, we have started using it as a manure. And this is a small scale business. In our campus also, we have a water treatment plant. We also have a wastewater treatment plant also. And the sludge obtained from the tanks are dried in the hot sun and then they are sold. Okay, that's how. And they are also used for manure for our own gardens within the campus. So you guys also can plan something for your university campus. If at all, if it is already done, it is well and good. So this sludge has got 98% nutrient value, okay, which is very good for the growth of plants and other trees. Yeah. And when I said I was focusing more on the concepts, sir told me to throw light on the design of few tanks. So let me start with the design of sedimentation tank. Before we get into any design, we must know what is the design criteria. Okay. And this course, whatever we are discussing now, every design has got certain design criteria. Okay. In simple words, they are nothing but the assumptions. Okay. If we are thorough with the assumptions, then easily you can design the tank. It is not like your reinforced concrete structures or steel structures. Here, most of the things are assumptions, and that assumptions are based on the repeated studies conducted by fellow researchers and also by practicality. You will get that idea, I'll tell you. The first one is the detention period. So how long the water is going to detain or retain in your tank. So for plain sedimentation, as I told you, it is 3 to 4 hours. And for coagulated sedimentation, it is 2.5 hours. Okay. Then comes the horizontal velocity of flow. It should not be more than 30 centimeters per minute. Fine. And then coming out with tank dimensions. When I say design, you are going to design the length and width of the tank and also the depth. So always the length is 3 times the width or 5 times the width of the tank. The length is always bigger. Okay. So you can assume this L is to B is 3:1 or 5:1. Fine. Suppose if you are going to design a circular tank, the diameter of the tank should not be more than 60 meters. Usually it will be within 20 to 40 meters. So these criteria will help you decide whether you have designed it in a proper way. The obtained value, the so-called answer for your problem, is within the prescribed standard limit or not. You will come to know that. Fine. Yeah. And always you can assume the depth as 3 meters. It should be within 2.5 to 5 meters. So when we design, the depth is very important because all the parameters will be unknown. So at least one parameter you have to assume. So usually we will start with assuming the depth of the tank. And the last one is the surface overflow rate, SOR. You can even call it as overflow rate. It is given by the formula volume of the water flow, that is velocity, to the surface area of the settling basin. And the values are given for plain sedimentation tank, it is 12,000 to 18,000 liters per day per meter square. And for flocculated water, it is 24,000 to 30,000 liters per day per meter square. So within that, your answer is there, means then your design is perfect. Okay. So before I go to the design problem, okay, let me play a short video about the sedimentation tank, how it works, the working principle, and then I will solve the problem. Yeah. Just a minute. Hope it's visible. Yes.
Yes, it's okay.
Proper flock has formed, it must be separated from the water through sedimentation or clarification. This process takes place in a rectangular, square, or round tank called a sedimentation basin or clarifier. It should be noted that direct filtration plants do not include a sedimentation or clarification unit process. Solid particles are kept in suspension in water as long as it flows with sufficient velocity and turbulence. Sedimentation removes flock by slowing the flow of water and decreasing turbulence. The heavier flock particles drop to the bottom and clarified water is collected from the top for filtration. Traditional sedimentation basins have 4 zones. 1. The influent or inlet zone decreases the velocity of the incoming water and distributes the flow evenly across the basin. 2. The settling zone provides the calm area necessary for the suspended material to settle. 3. The effluent zone provides a smooth transition from the settling zone to the effluent flow area. It's important that currents don't stir up any settled solids and carry them into this area. 4. The final zone is the sludge zone, where settled solids are separated from other particles in the settling zone. There are many variations in design for sedimentation basins. The 2 most common types are rectangular and circular clarifiers. In a rectangular clarifier, water flows across a rectangular basin. A circular sedimentation basin can be either center-fed or perimeter-fed, where water is introduced to the clarifier in the center or on the perimeter, where the water is allowed to flow unperturbed throughout the basin. Plates and tubes may also be used to increase the surface area available for settling, allowing for increased flow rates and enhanced settling in a smaller basin. As water travels up through them, instead of having to settle as much as 10 or 15 feet, particles have to settle only a matter of inches to reach the surface of a plate or tube. As particles continue to settle out and build up, they can slow down the tube or plate and eventually settle to the bottom of the basin.
Yeah. Hope you guys got some idea.
Somebody recently
about
asked
how
me,
it
Dave,
works, right?
what would
Sorry. Just give me a second. Yeah. So let's move on to 1 second. Yeah, let's move on to the design now. Hope all of you are clear with the working principle of sedimentation tank and the design criteria of sedimentation tank. Fine. Yeah, let us see the design problem. So we are going to design a rectangular sedimentation tank for treating 2.4 million liters of raw water per day. And the detention period may be assumed to be 3 hours. So this is what given in the problem. Sometimes they will just give you the population. For example, you are going to design a rectangular sedimentation tank for a population of 1 lakh. That's all. And that will be there in the problem. And rest of the parameters, everything we are going to assume. Okay, so in this case, detention period is given. If not, we can assume it as 2.5 hours to 3 hours. Yeah. So the first step would be to determine the volume of the tank. So which is given by the flow, which is already given in the problem, into the detention period. So in this case, it is 2.4 into 10 power 6 liters, right? So we are going to convert liters to meter cube. Just divided by 1000, you can convert liters to meter cube because 1000 liters is 1 meter cube. So we can convert this liter to meter cube and then multiply it with the detention period, which is given as 3 hours. So this 24 is nothing but in a day we have 24 hours, right? So you will get the answer or the volume of tank in meter cube. So this is meter cube, 3 hours divided by 24 hours. Gets cancelled. So finally you will get the volume in meter cube. Okay. Then, as I said, we are going to assume the depth of the tank as 3 meters. So the formula to determine the surface area is the volume of the tank divided by depth of the tank. In this case, it is 300 divided by 3 gives you 100 meters square. That is the area, surface area. And we are going to assume the length as 3 times the width. L is equal to 3b. Okay. So just substitute area is equal to length into width, L into b. So it is L into 3b is equal to 100, which is nothing but 3b square is equal to 100. So you can easily find out what is the width of the tank. Okay. And this width into 3 times gives you the length of the tank. That's all. So you have designed the tank. The length is 17.4 meters. Width is 5.8 meters. And depth you have assumed it as 3 meters. That's all. The last step is the check for the overflow rate or the surface loading rate, which is given by the water flow, 2.4 into 10 power 6 now. That divided by the area. That's what I told you. The surface overflow rate is the ratio of the volume of water, I mean the discharge, divided by the surface area of settling tank. So in this case, it is 2.4 into 10 power 6 divided by 100, which is 24,000 liters per day per meter square. And this value is the obtained value, 24,000. Which is less than 40,000 liters per day per meter square. So this is the prescribed standard value. So our value is less than the prescribed one. So whatever you have designed, the dimensions for the tank is on the safer side. Hope this is clear to all of you. Any doubts you can ask me during the query session. Okay. Shall I move on to the next slide? Okay, I will. Next is the coagulation. So what is happening in case of coagulation? So you guys got some idea about sedimentation, right? The theory of settling. So you have type 1, type 2, type 3 settling and all. And similarly, the next process is the coagulation. So we are speeding up the sedimentation process in simple words. Coagulants like aluminum sulfate, alum, will be added so that the impurities get connected to that. And the coagulant forms precipitate, trapping all the impurities. Okay, mixing. And finally, what happens? It precipitates and the trapped impurities are settling at the bottom of the tank. Same principle like sedimentation. Here you are adding the coagulants so that all the impurities are trapped and then they are settling at the bottom of the tank. That's it. Okay, so this coagulation is very important concept. Then comes the flocculation. So we have flocculators where all these paddles are rotated. For example, 50 rotations per minute, so that we introduce oxygen by the process of aeration, and then on the top of the tank, flocks are formed, FLOCS. Flocks are nothing but big lather when you use soap for washing clothes. So like that, it will be formed on the top surface of the tank. So this is how the raw water comes, and then you are adding the coagulant, mixing takes place. You can even add, using aerator, fast movement of water takes place at this zone. Then the water is allowed to circulate to the nearby tank, which is also known as the flocculator tank, where the flocks are formed on the top of the water tank. And finally, you get the treated water. As I said, always at the bottom, we get sludge, which has to be disposed, right? So it can be extracted, or you can again recirculate it to the process so that we get the purer form of the sludge. So this is how the flocculator works. Yes, diagram showing a clariflocculator from a water treatment plant in Kenya. Okay, then we have tube settlers. So these are all some of the types of tube settlers. We have horizontal, inclined, and lamellar separators. So all these are meant for collecting the solids at the bottom of the tank. So these tanks, everything work on the principle of settling due to gravity. Okay, and at last you get the clarified effluent, and then it will be taken to the next operational process. Okay, this is also a clarifier. So this settling tank, clarifier, flocculator, everything work on the same principle of gravity. Okay. Okay. Then comes the filtration. Very interesting and important unit operation. As I told, this is the treatment done by physical method, right? So you are going to filter. All the impurities will be removed by filtration method. So two types are there, slow sand, rapid sand filter. And the process of filtration, I'm not going to touch upon that. I'm just going to elaborate on the types of filters. Coming on to the process, we have mechanical straining and the sedimentation of particles. Biological action takes place, and by electrolytic action also filtration occurs. Okay, so what is the major objective of filtration? It is to remove the suspended particles from the water by passing through water through a medium of sand. It could be sand, gravel, coarse sand, and so on. So depending on that only, we decide the filtration units. Okay, so what is happening during the filtration? Everything is given to you clearly here. And this slide shows the components of a rapid sand filter. Just have a look at this slide. These are the layers of sand which I was discussing now. On top, you have coal or anthracite. Okay, layers, for example, 0.7 centimeters of coal will be kept at the top layer. And then we have sand here. And beneath we have coarse gravel this way. So these are all mediums of sand which act as a filtering media for the water to get filtered. And then they'll be collected on the top as wash troughs. Finally, the filtered water, which is collected at the bottom, will be taken to the Next, disinfection process. Okay. So always this rapid sand filter need to be backwashed, because you can imagine you have sand and coarse particles here. During filtration, what happens? I would say within a day, within 24 hours, clogging will start happening. So as an engineer, we have to ensure backwashing of the filter takes place in order to remove all the clogs and pores, so that the filtration happens without any disruption. Okay, without any interruption, the filtration should happen. Hope I'm clear to all of you. Okay, I'll show you the filtration process also as a short video. So this is how I told you: coal, sand, and then at the bottom you have gravel. So the particles are arranged in layers, and then underwater drains. This is the under drain system from where the water will be collected. Okay. Just a second, I'll play a video. Hope it is visible, right?
Yes, it's okay.
A complicated but much faster method is rapid sand filtration. Rapid sand filters operate up to 40 times faster than slow sand filters, but require a higher level of monitoring and control. Rapid sand filters aren't as deep as slow sand filters. They consist of a 6 to 18-inch bed of gravel covered with a 2.5-foot layer of sand. Rapid sand filters have no smutsticka. Rapid sand filters are more efficient than slow sand filters, but still require a larger footprint than more modern systems. For even more efficient filtration and higher flow rates within a smaller footprint, many utilities use high-rate filters. These filters use layered media and can produce up to 4 times the flow rates as rapid sand filters. There are several types of high-rate filters: dual media, multimedia, and deep bed monomedia. Dual media filters consist of a bed of sand covered with a layer of granulated anthracite coal. Multimedia filters are similar to dual media, but use 3 or more types of material. The most common configuration is a layer of garnet sand on bottom, silica sand in the middle, and coarse anthracite on top. In both dual and multimedia filters, different types of media are layered on top of one another. Generally, the larger the particles of a media, the lower it will be located in the filter. Gravel, which forms the base of most filters, stays at the bottom because it is larger and heavier than the sand on top. And the higher you go in the filter, the smaller the particles will become, with the exception of anthracite, which is found at the top. Anthracite has a lower weight per volume ratio or specific gravity, so it's able to sit on top of the smaller but denser sand particles below. Some mixing does occur at the interface level, but different media types generally remain stratified. The coarse anthracite layer at the top removes most of the suspended particles. What passes through is removed by the lower layers of media. The result is more of the filter depth is utilized for particle removal.
Yes, got some idea about how the filtration process are happening. Yeah. Okay. Now, yes. So as I said, we have 2 types of filters: slow sand and rapid sand filter. One major disadvantage of the slow sand filter is it requires enormous amount of space. Okay, like some small towns or villages, where the land rate is not that higher, we can go for slow sand filters. For cities like yours, as well as in our place, the usage of slow sand filters is, has become obsolete, I would say. So that's why we have gone for rapids and filters, which requires smaller space and more efficient compared to the 40 times, right? 40 times faster and efficient than slow sand filter. So that is why we prefer designing these rapids and filters for any town or city. And when we design this, the backwashing has to happen every 24 hours, and hence every day you are going to take care of the backwashing process, by which the clogged materials, everything will be removed. So as an engineer, when we design, you have to provide a standby unit. For example, we have 5 filters. As per the design, we are obtaining 5 filters. Always provide 1 more filter as a standby unit. So 5 plus 1, 6 filters must be provided. So that is how the design of rapids and filters goes on. Okay, and this is trickling filter. So I need separate session to discuss about the design aspects of trickling filter. I'm not touching upon that right now. Okay, so we'll have a look at how backwashing is happening before I go to chlorination, and then one more topic with that I'll wind up. Okay. That's it. Hope my screen is visible now. No?
Yes, this is visible right now.
Yes. This is how backwashing happens in a rapid sand filter. Just a 1-minute video, we'll just see. So this backwashing must be done every 24 hours. Just forwarding it. Yeah. So this backwashing is done in order to clean all the pores so that no clogging happens in the rapid sand filter. Okay, so this is how backwashing happens in a rapid sand filter. So now the water is filtered, okay, and it can be taken to the next operation and process, which is disinfection. Okay, stop here.
Laughed at me when I started my business. They said,
Okay, so the next process is the disinfection, where the filtered water from the rapid sand filter will definitely contain pathogenic bacteria, right? Now that bacteria has to be removed. For that, we go for the disinfection process, which can be done by boiling the water. You can add bromine or iodine and passing the water through UV rays Okay, a bit expensive. And also by using ozone, we can kill all the pathogenic bacteria, which are nothing but the disease-causing bacteria. And you can also use KMNO4, potassium permanganate, or by using excess lime, you can treat the water with silver. So these are all the methods by which the harmful pathogenic bacteria can be removed from the water, filtered water. Okay, so I can call it as the disinfection process or methods by which all the harmful bacteria can be removed. Then final, last step is the residue management. So by doing or conducting all these unit operations and process, residues are formed. So how are we going? This residue is nothing but the sludge. So how are we going to manage the sludge? So we can condition the sludge. You can remove water from the sludge, which is nothing but dewatering. You can dry the sludge and make use of it as a manure, as I told earlier. Go for stabilization of sludge. Incineration, you can just burn it off, but don't do that. It is not environment friendly technique. And finally, we can dispose the sludge. Yeah. To summarize, what are the options for your place, for Kurdistan, for University of Rapid? What can be done? What is being done in the water treatment plants in your locality? Okay. So as an engineer, you are all budding civil engineers. Within a year or two, you are going to be placed in a water treatment plant also. We don't know. So what are you supposed to do? See to that you make use of the resources available locally. Okay. For example, if you guys are coming over to Delhi, in my place, no, India, if you are coming to India, you have to understand the climatic conditions prevailing in that zone. Suppose if you are going to be placed in United Kingdom and the temperature conditions prevailing in United Kingdom and Iraq is totally different. Yes. So I was told by your faculty, even 48 degrees you guys go through during the summer, right? Here in Chennai also we will touch 40 maximum. So depending on the local resources, conditions, on how to fulfill the local requirements, we have to decide the options. Okay, so you can make use of the skills available locally in your area, and whatever technology we adopt, it should be socially acceptable. I will say a good example for this would be the reuse of wastewater. Okay, in our place also we have started reuse of wastewater for gardening only. I hope the same prevails over your place also. But in cities like Singapore and other places, they have started reusing the wastewater, the sewage, reused, treated sewage. They have started using it for bathing purpose, for washing their clothes. Hope all of you can accept it. So the people of Kurdistan or the people of Chennai are yet to accept it socially. Okay, there is a lot of changes must happen. So we, the environmental engineers, must create awareness about all these technologies and ensure it is accepted socially by your people. And the technology should be environment friendly and economically viable. Certain techniques in disinfection, like using ozone for removing the bacteria, is very expensive. We don't do that. Only Western countries are doing it. So we don't do that. Whatever technology we adopt, it should be economically viable. And any technology will have environmental impact. I don't deny that. But see to that which technology has got the least environmental impact. It could be short term or long term, but the impact should be the least. So when you decide the options, please ensure all these points are taken care of. And coming on to the opportunities, to summarize, it should be available for empowering the local governance in your area. And this should create regionally and nationally visible in case of development. You can also find out the opportunities such that it helps some form or any self-help groups And as I said, the qualified youths should be employed. And this will lead to the fine-tuning of national water management policies by your government. And finally, it should all result in the sustainability of the water sector goals. Like we say, earlier it was 3 R's, right? Reduce, reuse, recover. Now it has become 4 R. It is reduce, reuse, recycle, and recover. I was saying 5 R's also. R. It is refuse. Refuse. When someone is offering single-use plastic, you can say no. So refuse, reduce, reuse, recycle, and recover. So some kind of goals in order to keep our environment clean and to keep our people healthy. That should be our objective, I would say. Okay, so that is the sustainability of water sector goals. In this short note, I conclude my expert session. Thank you. Thank you all. Any doubts, you can let me know.
Thank you very much, Dr. Vandhana Devi, for this nice and informative presentation. Thank you very much, and also thank you for your sharing your experience. Well, now we'd like to ask the students, if you have any question, you can ask your question. And I got some question from the students, but now also if you have another question, you can send me. Dear Professor, there's one question from Mr. Diarco in the second stage. He say, is this process is possible for every types of water or just for specific type of water?
Good question. For any type of water, you can give the treatment. Okay, so any type of water. But usually we prefer the river water or the rainwater or the water from lake reservoirs, usually. Okay, but any type of water can be given this kind of treatment. Again, it will be expensive. That's it.
Thank you very much. The next question is Mr. Sahan in the third stage. He asked, how does the sand not mix it with the water while sand filtering? He means, he asked about the consolidation of the filter.
Yeah, okay. Yeah, it's a good question, I would say. In the filtering media, we are having the sand, gravel, I said, right? Now, in fact, I have showed you the video also. This sand is not the usual sand we have. It is chosen, such that selected, and then we form a filter media so that the water is not mixed up. Even during the backwashing, you would have seen the color of the water. It is turbid in nature. So let us not worry about the turbidity. Okay, this filtration process removes the toxicity, the contaminants present in the water. If it gets mixed up with some amount of soil, it is not going to be a problem. At the end of the filtration process, we will get only the pure filtered water. As you said, it will be mixed up during the process, but at the end of the treatment, end of the filtration, you will get only the filtered pure water. You can even do that small demo in your home. Just in some white cloth we used to filter our grandmother-in-law. Likewise, you can have this filtration media, sands and all, pour water, and then at the bottom you just get the pure filtered water, which will not contain sand or silt or clay.
Oh, thank you very much. Hopefully in the next week, I think our department has a plan to visit Dukan Dam, which provide a drinking water for Suleimani city. I think there's a water treatment plan there's available, and inshallah we will visit, and the students will see what's going on there practically. And the last question from the Mr. Kefi, he asked about the total cost of the project, and he asked that this process is cost effective, or we have another method that's less cost than this process or not?
Which process he is asking about? The
whole process, water treatment process.
Okay.
Yes.
This water treatment, all these processes, it is not being taken care or done by any individual, I would say. Not me or you are going to do this. It is all going to be developed, implemented, and installed by the government, not us. So it is going to be a very expensive project only. And you can imagine, I was telling this trickling filter, it will be 60 meters diameter. So you guys can imagine, you need large space, as well as these units are going to be very expensive. So it is not being done by any individual. I really like this question, but it will be taken care by the government. So the role of any government responsibility lies in the supply of good pure water to the public, right? So this is the responsibility of the government, I would say. But the civil engineers are only going to execute this operation, right? That is all.
The last question, again from Mr. Sahan, he asked, can we prevent the contamination through electricity? If yes, why waste chemical? I think it's not very clear question, but I mean, the question is, can we use the electricity in this process? I mean, in the water treatment plant, more specifically for chemical contaminant, pollutant or not? I think you mean this.
Okay. Usually our source of water like river will not have chemical contaminants unless the industrial wastewater is getting mixed up with that. Okay, in that case, we have to go for special treatment methods. Like usually we have industrial wastewater treatment technologies, which are very expensive, I would say. But somehow the final objective should be to remove all the toxicity and contaminants. So the usual your river water will not have so much of toxicity or contaminants. So all these water treatment methods, whatever we have seen today, will be of better usage for the treatment plant.
Okay, thank you very much once again.
Okay.
Sorry,
Yes.
we have 3 more questions if you have time.
Okay, okay, you can ask.
I send it to you, and now Ms. Shina has some question.
I have one question about the biological addition.
Your voice is not clear, Ms. Shana. Your voice is not clear, please.
Question about the biological addition. Vandhana said we are adding chemical or biological addition in the screening process for the unit operation. Can you give us an example about the biological?
Her voice is breaking again.
No, the sound is not clear, Ms. Shana. We can't hear.
Okay, I'm asking about the unit operation during the screening process.
Okay.
Dr. Vandhana mentioned that they are adding chemical addition or biological addition. What are these type of biological addition? Is it a specific type of?
I request her to text in the chat box.
Could you text your answer because your sound is not good?
Okay.
Sorry for that. Oh, Mr. Kefi, you can send me text message this question. Just, Mr. Kefi?
Can we call you by phone?
No. Now your voice is good. You can.
Okay.
Just read it.
What?
Oh.
Okay.
Let him read the question. No, I think this was.
What is the biological addition that you're adding for the water for suspending the contaminants?
Oh, biological addition.
Are they bacteria or what?
No. We are in the process of removing the harmful bacteria. Okay, so in the treatment process, usually we don't add any bacteria or any protozoa. We don't do that.
I don't know what's the problem with Ms. Shina. Your voice, we can't hear your voice.
The screening process, you told us that you're adding some biological additions. What are they?
Oh, have you mentioned something that there is some additive material in the screening process? Which type of
Screening.
chemical you mentioned in the
No.
slide?
Not in the
It's-
screening, I would say. No. No. Screening is just the bars which are meant for removing the larger objects.
Mhm.
Is-
Yes, screening is the first stage of
Yeah,
what a
first
treatment
stage.
plant just to separate the large pieces that mix with water.
True.
Okay, Mr. Kaifi, is there any question?
There is one more question.
Okay.
It's from Ms. Sahar from stage 3.
Mhm.
She said that what the remaining water, where do you use it? Or for example, you take it from to where?
The treated
Remaining
water,
water.
she means?
No, the remaining.
Okay, the wastewater. She asked about the wastewater from the treatment plant.
Yeah.
Yes,
Yeah.
yes, yes. Actually speaking, there won't be any wastewater at all. All these will be settlable solids, and then it will be converted as a sludge, which will be in semi-solid form. Okay, so we have only treated water, and then we'll have these settlable solids, and then the quantity of the unwanted water will be very less, and that will be discharged to the nearby lakes or rivers only. Yes. Usually it will be converted as a settlable solid and then as a sludge, which will be acting as a manure, as I told you.
أو بشيء لباك فلتر دا وكو قروليتا دو أترفرد دريتو بيوست جارج كتريتمنت بابوكلا. Thank you again. Thank you very much.
Thank you so much for the opportunity given to me. Thank you. Meet you all again.
Very much.
Thank
Yes,
you.
Thank you in advance
you.
for sharing your experience. It was very perfect and nice. Thank you again.
Thank you so much,
Now,
sir. Thank you.
That's the end of our webinar. Thank you again.
Thank you, sir.
Okay, bye-bye.